Good morning everyone, I'm Miss Rose and welcome to Discrete Mathematics. Our topic for today is about principle of counting. So our main objectives, first is define the principle of counting. Second, determine the permutation and combination. Third, determine Pascal's triangle. So in principle of counting, the first principle is simultaneous or successive events. Otherwise, this is the product principle. So in simultaneous or successive event or product principles, if the first event can occur in each ways, and if after the occurrence or at the same time, another event can occur in k ways, then the two events will happen h times k different ways. So example, a building has 5 outside doors. In how many ways can a person enter and leave by using different doors? In this problem, there are two events, which is the enter and leave. So if a person use only one door, enter and another door to leave. If he enter using one door, that he must leave using another door. So if he cannot use the same door where he entered because of the word different. So therefore, to enter, he can use any of the 5 doors and any of the four remaining doors to leave. So n equals to enter and leave. So n equals to enter, there is 5 doors, and going to multiply pag simultaneous or successive events or product principle, and leave. So in 5 doors, one door pumasok ka, there is 4 remaining doors. So n equals to 5 times 4 equals to 20. So the answer is 20 ways. There are 20 ways using the different doors. That is the simultaneous or successive event or the product principle. Next is the mutually exclusive events. So mutually exclusive event or the sum principle. So if the first event can occur in h ways and another event can occur in k ways, if the two events are mutually exclusive, then one or the other event can occur h plus k different ways. So example, in a deck of 52 playing cards, in how many ways can a person pick up queen or a king? So this event are mutually exclusive since there is no card which is a queen at the same time a king. So n equals queen or king. So n equals to how many queen in 52 playing cards? There are 4. And then or. Pag mutually exclusive, pag or siya, that is addition. Plus, in how many king in 52 playing cards? There are also 4. Add lang. So 4 plus 4, 8. So there are 8 ways can a person pick up a queen or king. So that's the mutually exclusive. Next is the arrangement. So in arrangements, if things are selected, it can be arranged in orderly manner, arrange them by group. In mathematics, that can be classified either permutation or combination. So in permutation is an order arrangement of any element or of a set. So first, the permutation of n different taking r at the same time is n permutation r equals to n factorial over n minus r factorial. That is the formula. Next, if the permutation of n different things taking n at the same time is permutation n pn equals to n factorial over n minus n factorial equals n factorial. That is the formula. But in permutation of n object with some like, the permutation of n object taking at the n at the time where q are alike, r are alike, and s are alike. So, n permutation n equals n factorial over p factorial q factorial and s factorial. That's the formula and so on. So next is if taking r at the same time where there are q, r, and s alike also. So n permutation r equals to n factorial n minus r factorial p factorial q factorial s factorial and so on. So that is the formula. Next, pag cyclic or ring permutation. So pag ring permutation ng formula n pn equals to n minus 1 factorial, or pag naka-braces and necklace ang permutation for braces or bracelets and necklace, the formula in permutation n minus 1 factorial over 2. So example, in things alike na formula. So how many permutation can be made from the word Mississippi? So first, state the given n, which is ilan daw ang word in the ilan letter in the word Mississippi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11. Next, ilan ang I? So from the word, ilan ang letter I from the word Mississippi? 1, 2, 3, 4. There are 4 letter I. And 4 also letter S. 1, 2, 3, 4. Then, dalawang P. 1, 2. So, from formula, na things alike, na n factorial, p factorial, q factorial, and s factorial. So, p equals to n factorial 11. Then 4 factorial, then 4 factorial, and 2 factorial. Using also calculator, that is 3,406.50. Basic naman, so p and 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then 4 times 3 times 2 times 1. 4 times 3 times 2 times 1 and 2 times 1. Multiply lahat. So 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So P equals to 399,168.0. Next is this. So 4 times 3 times 2 times 24. Also 24, then 2. So, divide lang. 399,180,000 times 24 times 24 times 2. So, equals to 3465.04. Pareha lang. Sa point something yung magkaiba. Next. So, in cyclic permutation, naka-round siya, ang arrangement. So, in how many ways can 4 people from a cycle? 4 people daw. 4 people. Yan. Sa reference. So, given 4 people in a cycle. Formula is from the cycle of ring permutation na NPN equals n minus 1 factorial. So, n equals to, n is 4 people, 4 minus 1 factorial. So, n equals to 3 factorial. So, 3 factorial basic calculation, 3 times 2 times 1. So, 3 times 2, 6 times 1, 6. So, n equals 6. There are 6 ways. So, that's the cyclic permutation. Next is the combination. Combination is a grouping arrangement of any elements of a set. So, the first is the combination of n. Different things taking all at a time is the formula na n combination r equals to n factorial over n minus r factorial r factorial. Next is the combination of n different things taking n at a time is formula n combination n equals to the n factorial over n minus n factorial equals to 1. Next is the number of combination of n object taking 1, 2, 3, and so on, n at a time. So, formula, n combination n equals to n combination 1 plus n combination 2 plus n combination 3, so on, plus n combination n. Alternative formula, alternative formula niya, alternative formula na n combination 1 or 2 or 3 and so on, n equals to 2 raised to n minus 1. This is simply as formula. And number of combination n object taking 1, 2, 3 and so on. So next, that in the relation between the permutation and combination. In the arrangement of n object taking R at a time, the ordered arrangement is related to the grouping arrangement. So the formula na n combination R equals to n factorial over n minus R factorial R factorial. Otherwise, my other formula, which is n combination equals to n permutation R over R factorial. So that is the between permutation to formula. Next, let's go to example. Example 1, 6 people are on sinking yacht. There are 4 life jackets. How many combination of survivors are there? So let's take the given. So there are 6 people on the sinking yacht. So that is the N. And 4 life jacket. That is the R. So the formula using is ito. So that combination of n different things taking R at the same time. So NCR equals to n combination n factorial over n minus R factorial. R factorial. So n equals to n, which is 6 factorial over 6 minus 4 factorial. R is 4 factorial. So, and simply as way of solving 6 times 5, 6 times 4, 6 times 3, 6 times 2, 6 times 1 over 6 minus 4. 6 minus 4 is 2. Factorial is 2 factorial of, so 4 and 4. 4 times 3 times 2 times 2 factorial, that is 2 times 1. So equals to 6 times 5 times 4 times 3 times 2 times 1 equals to 720 using calculator over, next is 4 times 3 times 2 times 1 equals to 24. Then 2 factorial equals to 720 divided by 2 times 24 equals to 15. N equals to 15. So there's 15 combination of survivor. Next example. In how many ways can you invite one or more of 5 to a party? So there, in this example, n objects taking 1 or 2. It's possible for you to invite one of your friends, 2 of them, 3 of them, 4 of them, or 5 of them. So the formula is this. The number combination of n object taking 1 to 3 and so on. This formula or this formula. So there are given 5 friends to a party. So 5 friends to a party, the formula 5 C1 or 2 or 3, so on, n equals to 5 C1 plus 5 C2 plus 5 C3 plus 5 C4 plus 5 C4. Or mas madali mag-solve for alternative formula, which is in 5's combination 1 or 2 or 3. So n equals to 2 raised to n minus 1. So it is n minus 5. 2 raised to 5 minus 1 equals to 2 raised to 5 equals to 32 minus 1 equals to 31. So 31 ways we invite 1 or more to. So that's the answer, 31 ways. Next is Pascal's triangle to binomial expansion. So the expansion of a plus b is to n. The coefficient of expansion may be obtained using Pascal's triangle. So, solving or write this Pascal's triangle first. Write 1, then add both sides ng 1, then add mo siya. So 1 plus 1 is 2. Then add another 1, both sides, and 1 plus 2 is 3. 2 plus 1 is 3. Then add both sides ng 1. Same process, i-add mo lang siya. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Then add both sides ng 1. Now 1 plus 1 is 5. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. Then add both sides ng 5. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 2 is 20. 10 plus 5 is 15. 10 plus 1 is 6. 1 both sides, and so on. So, in binomial expansion, start with b1. So, a plus b raised to n, which is 0, we start to 0 equals to 1. Next is a plus b raised to 1. So, in Pascal's triangle, that is 1 and 1. So, understood na a, may 1 yun siya, and also the b, may 1. So, a plus b. Next, a plus b squared equals to, take pattern, this pattern na, a squared plus 2 ab plus b squared. How to check if tama ang pattern? So, a plus b squared equals to a squared plus 2 ab plus b squared. So, dalawang sin squared, dalawang a plus b. So, a plus b, a plus b. So, a times a equals to, in exponential term, multiplication, ang exponent niya is addition. So, since understood ng a, may 1 din siya, exponent. So, addition ng 1 plus 1 is 2. Plus, a times b, so ab. Plus, a times, b times a, so ba. Plus, b times b. So, to 1 exponent equals to b squared. So, a squared plus ab plus ba, since understood na may 1, yan siya. So, 2ab plus b squared. So, that is correct and same pattern. Paano ba siya malalaman pa? Ang exponent niya is decreased and increasing. So, there are the properties of binomial theorem, and the expansion of x and y raised to n, or ang gamit na variables a plus b raised to n. So, the first term is a and a raised to n, or a x raised to n, or a raised to n. So, the last term would be y raised to n, or kung gamit niya na variable is b raised to n. So, the exponent of x or a, the variable, decreases by 1. Then, the exponent of y or b increases by 1. So, the sum of exponent of each term is n. And the number of terms is n plus 1. The coefficient of symmetrical terms are equal. So that is the properties that we need to read. So what is the formula term involving y? So yr term equals to n cr x n minus r x raised to n minus r y raised to r, where NCR or n combination r is the n factorial over n minus r factorial. For example, this formula. Find the term involving x raised to 6 and x squared plus y over x raised to 12. So, state the given n raised to 12, then the y or x 6. So then the r also r 6. That's r. The r is 6. So x raised to 6 and cr x raised to n minus r y raised to r. So that is the formula. Equals to ang n is 12, combination with 6 times x squared, x squared, then 12 minus 6, then xr, which is this xr, times 1 over x minus 6. So 12 factorial into this, 12 factorial, and 6 factorial, 6 factorial. Formula na equals to 12 factorial, 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 2 times 5 times 3 times 8 times 6 x 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 6 times 5 times 4 times 3 times 2 times 4 6 times 5 times 4 times 3 times 2 times 11, 12 times 11, 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times 2 4 7 9 0 0 1 0 over 6 times 5 6 times 5 times 4 times 3 times 2 times 1 is 720. So 720 equals to 479,001,600 divided by 720 times 8 equals to 924. Then my variable